Okay, today I'm going to speak about Oracle REST data service with high availability on Oracle Cloud Infrastructure. If you go to Google, you can find this URL very quickly on the OCI Architecture Center. So you can see here the description of the architecture. It means you do not want to use the ORDS that is automatically installed with the autonomous database, for me and HTTP, and you want to manage yourself VM with ORDS, and so several VM in order to have high availability. As you can see, if the ORDS number 2 stopped, then it's not a problem because this one is running and I will have no error. Okay. If you go at the end of this page, you can find here deploy to Oracle Cloud. It means you have a Terraform stack in order to create automatically all the components of this architecture. So you are going to create the network, the VM, the load balancer, register the VM behind the load balancer. You can choose 1, 2, 3, and so on, a number of ORDS that you want. It's very nice. Okay. Very, very nice. Personally, I didn't do that because I want to master the installation, to better understand how to install ORDS and so on and so on. So I did that manually. Okay. I have an autonomous ATP with 4 eCPU. Okay. 1 terabyte the storage. I have 2 VM, ORDS 1, ORDS 2, and I stand ORDS on this 2 VM, and I have a load balancer here, load balancer with a listener, okay, with a listener here, and this listener is listening to the port 8080, okay, this is the HTTP port of ORDS. I have a backend ORDS, backend. As you can see, my 2 VM with the 2 private addresses. Okay, so I install myself ORDS that is running here in the HTTP mode. You can choose HTTP or HTTPS. Sure, for a production site, use please HTTPS and not HTTP, but personally, in order to do the demo and to do the load bench, I don't want to use HTTPS because in this case, I will have to create certificate, SSL, with a good name, having a public domain name, and so on and so on. And the certificate for ORDS, certificate for load balancing, and it's boring. Okay, so today it's a test with HTTP, but you're on production site, use HTTPS. It's okay. Okay. To the test here, I did a connection on the load balancer. I used a domain name here in order to mask the IP address. It's okay. As you can see, I did several things, but the main thing is I create 2 auto rest on DAPT and table amp. It means when you are using auto rest, it's so simple. You said auto rest on table amp and you can do upset, create, update, delete on the table employee, because I want to do a small bench, very small, on the table employee. Okay. I have security with OAuth. It means I created a OAuth client and I protected the AutoRest API. Here I can get the bearer token in order to be able to call the REST API. Okay. Please use OAuth and not basic authentication with user password of the database, because OAuth is really fast compared to the basic auth with database username and password. Okay. The OAuth bearer is here. The URL in order to check that the authorize and employees table hump is okay. It doesn't matter if you see the bearer, because this bearer will be token will be not available in some minutes. Okay, so send. Okay, nice. I got all the employee. And now I want to do a small bench. It means I'm going to use Gmeter, and as you see, I will create and insert employee in the table employee, because as you know, each time that I'm doing a video, it's for a use case of a customer, and the customer has a mobile application deployed in the world, and for this mobile application, the customer is using ORDS in order to get data from the mobiles through HTTP REST. Okay, and the rate should be something like 4,000 inserts per second. Personally, okay, my architecture is not so big, so I just want to reach something like 1,000 inserts per second. It's nice, only with 4 CPU. It means only 2 CPU for ATP, so very small DB, and just 2 VM with 2 CPU, so a small architecture. I will insert, so employee on the table amp with a post, okay, and I will use here the bearer. Sure, I need to use the same bearer that is here, okay, if I want to run. Okay, nice. Number of thread, 60 user, ramp-up period, 60 seconds, but I have 2 processes in order to inject data, okay, in the ATP, okay. So I have another, you see, Gmeter agent. So when I will start the little bench, these 2 processes, this one and this one, will create 60 user and call the REST API in order to create employee. For the moment, I only have 14 employees. Okay, so let's go. I'm going to start. Okay, start. This is the agent on my local. Sure, when you are using Gmeter, you can have a lot of agents deployed on several VM as you want. Okay, start all for me. And okay, to be honest, we are not the same day because I had to do some modification, and specifically I have a thread group of 60 users, and I have 2 processes that creating load. Okay, so it means that I had to increase the maximum number of the JDBC connection in ORDS. It is just a parameter. Okay, so now I can run the bench, mini bench, and we will see the result. Let's go. It's okay. So it started. Okay. As you can see, I run the bench before, and the CPU utilization of ATP was around 50%, so it's okay. And concerning ORDS, I reached 70%. So we can see that the architecture is okay to be able to run something like X thousand transactions per second. I am happy to have 2 ORDS because it means that only one ORDS here could not do the job because the VM has only 2 OCPU. So maybe one ORDS with more OCPU is okay, but the goal of the video is to have high availability. So it's nice. Okay, I will come back in a few minutes to show you the end of the band, and I hope that we will reach 100,000 per transaction per second. Okay, awesome, it's finished. We reached 1007 transactions per second, so it's okay. We got 0 error. The goal of the video was to demonstrate to you that we can have a high availability architecture with ORDS. Here we have several ORDS running in VM behind a load balancer. You can scale on the ORDS part, as you can add other ORDS as you want, and you can scale on autonomous transaction database, because you know that the autonomous database can automatically scale, or you can manually scale autonomous transaction database without service interruption, increasing the number of eCPU of the database. So you have a nice architecture that can scale without service interruption, up and down. Thank you for your attention.